Okay, this camera's been giving me some trouble here, so I will go over that again. This question number 4 is looking at the conditional distribution given that there was no reoccurrence. So we will take each of these values against the total of that column. Since we're given an outcome and we want to know the conditional response of the treatment, we will then take the numbers in that column and compare them to the total of that column, and we end up with 3 different marginal distributions. Problem 5 goes back to the prairie dog question again, and it looks for a conditional distribution, and they said given a proximity, either near or far, what was the conditional distribution that a prairie dog would either make a call or not make a call? And so if you take the data, this would be about 26.6 that they would give a call if the predator was near, 73.4% that they would make no call if the predator was near. And if the predator was far, you'd have about 41% and about 59% that would give no call. Based on these numbers, you might conclude that there's a good chance that whether the predator is near or far, the prairie dogs are not going to run a high chance of making a call. I guess it's every man for yourself in prairie dog land. Now, question B says, what about the probability of a call when the predator is far? Well, it's a little higher than if the predator is near, but again, there's a higher chance that there would be no call. Okay. Okay, in problem 7, we're given a chart, a couple charts here dealing with kidney stones and a couple treatments. And they break the 2 charts into small kidney stones and another chart for large kidney stones. And they have 2 treatments open in PCNL. And they ask for the total successes for each of the procedures, considering both the small and large combined. So in the open procedure, we combined the 2 values, both small and large, 81 plus 192, over the total of that, over the total of the success column between the 2 charts, for a total of 562. So that came out to be about 49%. Then for the PCNL, we did the same thing. We took the small value and the large value and divided by the total of the success line, and we came out with approximately 51%. In part B, they ask us to look at the total success of small and the total success of large and find out the percent of success of those. So we add up the successes of the 2 types of operation, 81 and 234, out of the total of 357 for the successes in the small, and we do the same thing in the large. We find out that the small success is 88% and the success in the large stones is 86%. In part C, we look at each individual. They look at the success for each of the different types of operations or treatments, and they look at it in terms of both the small and the large. So the small open, well, it turns out to be 81 out of 357, and the small PCNL turns out to be 234 out of 357. So those percents came out to be about 23 and 65, or 66, rounding off a little bit. They also did the same thing for the large stones, large open, and large PCNL. And those were 192 out of 247 and 55 out of 247. And that turned out to be 77% and about 23%. And then if you look at those comparisons, it appears that the highest percentages for small were using the PCNL procedure, and the highest percentage for large stones was using open surgery. So from those two conditional percents, you're able to see which of those works best for that particular size stone. In questions 9, 10, 11, 12, we're given a table using the treatment of echinacea to treat for colds. And the various treatment groupings, 7 days before being infected, and they purposely infected or exposed these people, they gave them echinacea at the time of exposure, and then a group that had a placebo or didn't receive any particular treatment. So the outcomes, you either had a cold or you didn't have a cold. Just a sort of, you either did or you didn't. So the data there showed up, and the question was, how many subjects have a cold? Well, given that they're cold, we want to know how many subjects were in that list. And then we just total that list, and we add up each of those values, and we find out that 219 people had a cold after being exposed. And in question 10, they say, well, how many subjects in all were in the study? Well, then I take the total of the cold column and the total of the no cold column, add it together, and I get a total of 351 people were in the testing. In number 11, it asks us for the percent diagnosis with cold. So they want to know the percent that were diagnosed with a cold. So what we would do is take 219 over 351, and that turns out to be about 62% were diagnosed with a cold. Number 12, dealing with the diagnosis with 11, it asks, what is the marginal distribution of the total colds? So our marginal distribution would be this value over this. And so that's how we would get that. In number 13, they're talking about the group that was given a placebo, and they want to know the percent with a cold that received, given the fact that they were given a placebo, what is the percent of people? So we're going to say, given that they were given a placebo, we're going to add that across, and our total for that row is 88. So we're going to do a marginal distribution of people with a cold that were given that we had given them a placebo. So we'll take 58 divided by 88, and that will be about 65%. And that's question number 13. In question number 14, they look at the conditional distribution given a specific treatment, i.e. placebo. Use placebo row, and then we take if we wanted a conditional, we would have 58 over 88 or 30 over 88 to find out the conditional distribution of either having a cold or not having a cold. In number 15, we're looking at given that they had a cold, the conditional distribution that of a placebo, and that would be 58 over 219 for about 26%. And number 16 is based on number 15, the conditional distribution of treatment given an outcome cold. So then we could look at, given that we have a cold, we could determine the conditional distribution of the echinacea given 7 days prior, given at the time of exposure. So we would take each of those values and divide by 219. So we could figure out the conditional distribution given that they had actually contracted a cold. And then it asks, well, how many bars? Based on that question, how many bars would there be? And then there would be 3 bars, 73 over 219, 88 over 219, and 58 over 219. So you would have a chart with 3 bars, and you would have the 7 days before, the time of, and the placebo group. And so that would be your chart of that data. In problem 20, we're looking at gender of an egg versus the order in which the egg was laid. The first egg laid, the second, the third, the fourth. I'm not sure how they determined the order, if they were using one chicken or multiple chickens, or how that went about. But one of the first things we do is we take the total of each row and each column, and then we get a grand total of 95 eggs were involved in this experiment. Well, the first question is, what percent of the male are first egg? So this is your given. What percent of the male? So we're going to use this column, and we're going to use this total. So this is going to be first egg. So that's going to be 17 out of 45. That will be how we get that percent. The second question is, what percent of the first eggs are male? So then, on this case, our given is the first egg, and then we're going to find out, given that it is the first egg, what percent are male. So in this case, it will be 17 out of 27, where this total is 27 that we're using for that one. So the question is asked both ways, and they're asking a conditional. This is a conditional question. What percent of male given that are first? So given that they're male, what is the chance or conditional probability or conditional distribution that they are the first egg? So that's what they're doing in number 20. In problem 21, it says, give the conditional distribution of egg order among males. The among males, this is your given statement. Given that they are males, what is the conditional distribution of each of the egg orders? So we're going to take each of these values relative to the total of that row. So we'd have 7 over 45, 16 over 45, 17, 7 and 5 all over 45 to get each of those distributions. And as it turns out, the first is 38%, next one is 36%, and the next one is 16, and then 11% going across. And those would total up to be approximately 100 if you didn't round off to bed. In problem 22, it asks us to compare the male to female of the first egg, and asks us why that is not necessarily a good determination of the percentage of male to female. Well, you're looking at several columns, first, second, third, and fourth egg. If you look at the totals of male to female, they're fairly well balanced in terms of the totals. So if we were just to look at the first egg, we might get a misleading concept that most of the eggs were male. And that's not true. As you go along here, we find out that there's a higher tendency for the eggs to be female than it is for male over the distance of several eggs being laid. So if we just looked at the first egg, first order egg, and compared male to female, we might have a misleading concept that most of the eggs were male.